All right, so welcome to the fourth section of this unit. Yes, I know it's chapter 5, but it goes along with everything that we're talking about. All right, so we've talked about divisibility, we've talked about prime factorization, and we've talked about the greatest common factor. Well, the least common multiple is different, okay? The least common multiple to me is the hardest to kind of grasp at first, but once you do, then it's really easy. Okay? Same way with the greatest common factor. The greatest common factor, once you kind of grasp how to break down a number to its prime factors and pull out what they have in common, it's the easiest thing to do. Okay? Least common multiple is just a little bit different. The least common multiple is the smallest number that is a multiple of two or more numbers. Okay? It's the smallest number that these numbers will divide into evenly. Okay, not what will divide into 8 and 12, but what 8 and 12 will divide into. Okay, so for instance, 96, 8 and 12 will both divide into 96, but that may not be the smallest number that 8 and 12 will first divide into. Okay, so we're looking for what both of these numbers will divide into. Okay, the lowest common multiple. Remember that a multiple is like 8 times 1. All right, 8 is a multiple of 8. 16 is a multiple of 8 because that's 8 times 2. 24 is a multiple of 8 because it's 8 times 3. All right, those are multiples, okay, of a number. All right, so if you use, there are two different ways that you can do this. You can do a list method, and you can do the prime factorization. I'm going to show you both, but the list method is a lot more intensive because the farther apart your numbers get, the harder it is for the list method to work because sometimes you have to list so many numbers in order to finally get to it. Okay? So we want to make sure that we are using the best method, which to me is the prime factorization, and is also the easiest to me. Okay, so the list method, if I were to try and find the least common multiple of 8 and 12 through the list method, I list out the multiples of 8. 8 times 1 is 8, 8 times 2 is 16, 8 times 3 is 24, 8 times 4 is 32, 8 times 5 is 40. So I just listed out the first 5. 12. 12 times 1 is 12, 12 times 2 is 24, 12 times 3 is 36, 12 times 4 is 48, 12 times 5 is 60. And then we go and we see if we have anything in common. And if we don't have a number in common, a multiple in common, then we would keep going with the list method until we do. Okay? But luckily we do. 24 is the lowest common multiple, the least common multiple between 8 and 12. It is the first number that both 8 and 12 will divide into. 24 is the first number. Okay? Because 8 will divide into 8, but 12 won't divide into 8. 8 will divide into, or 12 will divide into 24, all right, and so will 8. Okay? 8 will divide into 16, but 12 won't. Okay? So 24 was the first number that both numbers will divide into. Okay? Now, through prime factorization, which I find to be the easier method, all right, you break down 8 and 12 into its prime factors. So 4 times 2, and then 2 times 2. So 2 to the third power is the prime factorization of 8. Okay? 12 is 2 times 2 times 3. Okay? 2 times 2 times 3. So 2 squared times 3. Now, how you find the prime factorization from that is write down the prime numbers that both of these numbers have. All right? Well, both numbers have a 2. Or write down the prime numbers between both of these, not that both have. Okay? So 8 has 2, 12 has a 2, but also has a 3. And then what you do is you write the greatest number of the prime numbers that one number has. So which number has the most 2's? Well, 8 does. How many? 3. All right? So what about 3's? Well, 8 doesn't have any 3's, 12 has a 3, and it only has 1. So if you were to multiply this together, you're going to get 24. So you pull out all the prime numbers that both of these numbers have. Not that what they have in common, but all the prime numbers that 8 has, all the prime numbers that 12 has. Well, all the prime numbers that 8 had was 2, and all the prime numbers that 12 had was 2 and 3. Well, I already have 2 listed, so then I just have to write 3. Then you look at each number and which one has the largest amount of 2's. Well, 8 does. It has 3 of them, so 2 to the third. And then 12, it has 3. It only has 1, 24. Okay? So the least common multiple of 8 and 12 is 24. All right? So let's look at this. 12, 10, and 15. Once again, going to break it down. We already broke down 12 before. 2 squared times 3. Okay? 10 is 2 times 5, and 15 is 3 times 5. So now we want to list all the prime numbers between the 3 of these numbers. All right? Well, we have a 2. We have a 3. We have a 5. There's no other prime numbers. So then we look at the 2's. Which number has the largest amount of 2's? Well, that'd be 12. It had 2 of them. So we'd write 2 squared. Then 3's. Well, 15 had a 3 and 12 had a 3, but they only each had 1, so we just leave it as 3. Same way with 5. 10 had a 5, 15 had a 5. They each only had 1, so you only list it once. Then you multiply together. 4 times 3 is 12, times 5 is 60. So the greatest, or the least common multiple of 12, 10, and 15 is 60. That is the smallest number that all 3 of these numbers will divide into. Okay? So go ahead and do the practice problems. Come in with any questions you might have, and then we'll try to work through them tomorrow. Thanks.